Alright, this lesson is a bit more intense than most, so take your time and go through this carefully. If there's any part of the previous lessons that you're still stuck on, please go back and re-watch that material because you will need everything you've learned up until now to understand this lesson. So in the previous lesson, we learned how to calculate the maximum values that can be stored in a set number of bits. For example, we learned that if given 16 bits of storage space, which is 2 bytes, the highest integer number that can be stored is 65,535, which is 2 to the power of 16 minus 1. Here, I want to expand on this a bit more. Let's consider that we still have 2 bytes to work with, 16 bits, but we want to store both positive and negative numbers. You should remember from previous lessons that this means we need to have a sign bit. The purpose of this lesson is to show you how to calculate the minimum and maximum values for signed integers. You should remember from previous lessons that using a sign bit cuts in half the total numbers that can be represented. But you are now able to count in 2 directions, positive and negative. Let's examine the situation when we have 4 bits to work with, and one of those bits is a sign bit. Remember from the previous lesson that the total number of possibilities that can be stored in 4 bits is 16 total possibilities. If we were to use one of those bits as a sign bit, we now allow for 2 sets of 8 possibilities. One set positive and the other set negative. If you need any review on this concept, review the lesson on the sign bit and feel free to ask any questions you need to. If you remember from the lesson on the sign bit, we had a curious situation. We had a positive 0 and a negative 0. This is not very efficient since we are wasting a value, since we only need to represent 0 in one way. So this is the table that I showed you in that lesson, where we start at 0 and we count to 7, and then we do it again with negative numbers, again starting at 0 and counting to negative 7. If we choose to not use 0 twice, then that frees up an extra value that we can use. We could set this extra value to anything we want. If we wanted to, we could set it to negative 8, and then our method would make it possible to show all the numbers from negative 8 through positive 7. Also, this makes sense because for the extra value, the sign bit is already set to indicate that this is a negative number. Of course, this creates problems if you want to easily be able to add or subtract or perform other mathematical operations using this system, but we will get to that later. The exact mechanism by which this is done is still outside of the scope of this lesson, and the example I'm showing you here is for demonstrative purposes only. So I want you to remember the idea here is that you have 0 and then you effectively have negative 0, and so what we're saying is since we already have 0 once, we're going to do something different with this value, and because this bit, which if you remember is the sign bit, since it's already set to 1, then what we're going to do is we're going to make this number negative, which means now that we have a total of 7 positive numbers, not including 0, and we'll have a total of 8 negative numbers. Because this isn't going to be 0, we're going to make it something else. Keep in mind that we will have exactly half of our values have the sign bit set to 0, and exactly half of the values have the sign bit set to 1. However, one of the values where the sign bit is set to 0 is going to be 0. And the corresponding value where the sign bit is set to 1 is not going to be 0, because setting it to 0 would be effectively wasting a value. We want to use that value for something else. So let me show you a table that makes this more clear. With any number of bits, you're going to always start with 0, which is setting every bit to 0. And then you count 1, 2, and so on until you have filled up every single bit except the sign bit, which is going to stay 0 to indicate that it is a positive number. When the sign bit is not 0, when the sign bit is set to 1, then you're going to have negative numbers. So the question that we need to answer is how many total positive numbers and how many total negative numbers. And this is how it works. Remember that exactly half of the values are going to have the sign bit set to 0, and exactly half the values are going to have the sign bit set to 1. However, one of the values when the sign bit is set to 0 is the number 0. So let's look at it a different way. If we have a total number of possibilities, which we're going to call t for the total number of possibilities, then the total number of possibilities where the sign bit is set to 0 is going to be exactly 1/2 of t. The total number of possibilities where the sign bit is set to 1 is also going to be 1/2 of t. Now, of course, another way of saying 1/2 of t is just to say t divided by 2. Except in the case of positive numbers, we're going to subtract 1 because we have the value 0 to consider. So the total number of positive numbers you can have is going to be t divided by 2 minus 1. Whereas the total number of negative numbers that you can have is going to be t divided by 2. Alright, so for signed integer values, the maximum value for positive numbers is going to be the total number of possibilities divided by 2 and then subtract 1 in order to account for 0. Another way of saying the total number of possibilities is saying 2 to the power of n, where n is the number of bits. For example, if you have 4 bits, then that would be 2 to the power of 4, which is 16. Half of 16 would give us 8, and then 8 minus 1 gives us 7. And so the greatest number that we can store in 4 bits, if it is a signed value for positive numbers, is the number 7. For negative numbers, the minimum value is the total number of possibilities divided by 2, but make that into a negative number. And another way of saying that is, of course, the total number of possibilities divided by negative 2. And another way of saying that, because the total number of possibilities is 2 to the power of n, where n is the number of bits, you could just simply say 2 to the power of n divided by negative 2 will give you your lowest possible negative number. Alright, so let's look at this example when we have 16 bits, which is 2 bytes. That means we have 65,536 total possibilities, of which half of those possibilities, meaning 32,768, will have the sign bit set to 0, and half of those possibilities will have the sign bit set to 1. So in order to figure out the maximum and minimum values in this case, we simply take half of the total number of possibilities and subtract 1 in order to get the highest possible positive number, and we simply take half of these possibilities and make it into a negative number in order to know the minimum number. At this point, given any number of bits, you should be able to know how to calculate the total number of possibilities, the highest possible positive number if it is signed or unsigned, and the lowest possible negative number if it is signed.